All right, ladies and gentlemen, welcome back to Math 1800, Wayne State University. My name is Rush Mahaber. Today we're going to discuss the beginning of what is going to be the push of starting to graph polynomial and rational polynomial functions, okay? We're just going to start with the brass tacks and the basics, and everything starts with quadratics, okay? So what's a quadratic? Quadratic is a degree 2. So recall, if I can get this to work here, let me get some space. Recall, quadratics are degree 2. And what does degree 2 mean? That means the highest exponent on the quadratic is 2. So example of a quadratic, or any quadratic for that matter, would be f of x equals ax squared plus bx plus c, where a, b, and c are real numbers. This is a way of saying elements of the real number system. Don't get caught up on that. I'm just doing that because I don't feel like actually saying are real numbers. So all quadratics look like this guy. And if you've seen a quadratic before, you know they all look like this guy. This is like the granddaddy of all quadratics, which is just this guy, x squared, right? Now, any other quadratic will look like him, just shifted around. But we're always interested in one piece of the quadratic. And which piece is that? If you're wondering what I mean by a piece, I mean one point on the quadratic. That's this turning point. This turning point has a very special name. It's called the vertex. Now, for the basic granddaddy of all quadratics, that's just 0, 0. But how do you know if we had a quadratic that was sitting in space over here or upside down down here, how do I know what that vertex is? Well, we're going to talk about that, okay? So quadratics in general always have, and this is the reason why it's so important, is because quadratics, and I'm going to erase all this crap, so don't worry about it being in our space. If it looks like this, there's a the vertex is the maximum, right, if it's upside down. So if I have a function and I say at what point, oh my god, that is so crooked. I can't believe how crooked that is. I'll redraw that. That's terrible. If I said at what time or month, right, do we get the maximum amount, if this is like dollars, you could tell me at 6 months the maximum amount of our, I don't know, products or like economics, whatever the case is. Like if you think about our last section of modeling, we could create a modeling function that's quadratic, and then we can actually say at 6 months we have $250. But if you go any further past that, it starts to depreciate. Okay, it's kind of, this is actually something that is huge that you will use. It's and actually in calculus, it'll be called optimization. So I'm going to show you what we normally do when all this happens, and then I'm going to magnify you, or mystify you, I think is the word, mystify you by how this normally happens. So, good news. Here we go. So let's say we had this quadratic, f of x equals x squared plus 4x plus, minus 5. Okay, well, in order to find this in general, and I'm going to go back to our last example, in this case, all quadratics will look of this form. That is ax plus h squared plus k. And I've seen some textbooks say plus h or minus h, depending on who you are. And why are we always interested in this form? Because in general, the vertex is going to be the opposite of h and k. So that tells you this. So in this case, the h and k in the original function are both 0. If I was to draw it, it would look like this. So it's x squared, but this thing is plus 0, hence nothing happened. Okay. Now, don't get me wrong. We've talked about transforming and shifting and reflecting quadratics, okay? But finding that vertex is the biggest piece of the pie. So in the past, the method to find the vertex, notice I'm saying in the past, the method to find vertex is called completing the square. But I'm going to be honest with you, completing the square is important in many fields, statistics being one of them, but it's not really that important when we're talking about STEM or traditional mathematics, because when you get to calculus and you learn what a derivative is, you don't really see completing the square too much often, but it's a technique you should know how to do, right? So they'll remind you when the time comes. I'll also remind you what we do here. Completing the square is a method of factoring out the x's. So what I'm going to do is I'm going to show you. We put all the x's here, And then I'm going to put my minus 5 over here. Now, here's the idea behind completing the square. Completing the square is filling in the number that allows us to make this thing factorable. So what do we put here that allows us to make this thing factorable? And not just any old factorable. It has to be factored into two factors that are the same. Okay, and then that allows us to say that factor squared. Okay, so that's kind of what we're trying to do. So how do we figure this out? Well, somebody, I think his name was Galois, said, okay, just take the b term, and in this case is 4 divided by, take half of it. I'm not going to say divide by 2, I'm going to say half of it, and then square it. Okay, so the b term here is 4, half of it is 2, squaring it gives you a 4, squaring it gives you a 4, and then that's the number you're going to put in. And then at the exact same time, you're going to subtract it out. What it is we're splitting up this balance of 0. So this piece over here would allow us to factor this into x plus 2, which gives us x plus 2 squared. And then this, we'll say it's minus 9. So for this original function, the vertex will be negative 2 comma negative 9. Now, you see how much work that is and how complex that is, and it's a beautiful, like, as a matter of fact, I learned this over quadratic formula. I would just complete the square every single time and then just solve directly for x, which works out very, very nicely, by the way. But now that we're in 1800 and you're getting ready to learn what a derivative is, you can just use, so that's why I said in the past. Now, here's another piece of the puzzle, and it's called the vertex formula. So the vertex formula is particularly this. In order to find the vertex, all you do is take negative b over 2a, right, where a, b, and c are your coefficients. And then once you find out what that is, plug it back into your function, and that'll give you what your vertex is. So for the example we just did, b is 1, a is 1, b is 4, c is minus 5. Alright, so now that I've highlighted those, let's rock and roll. Okay, so what does this mean? This means negative b over 2a will be negative 4 over 2 times 1, which is negative 2. Doesn't that look really, really familiar? So that means this is negative 2. Well, good news, we knew that already, didn't we? So, yeah, it worked out pretty well. Now, how do we figure out that the other piece was negative 9? Well, we just got to plug in our negative 2. Now, can you do this? I hope so. So, f of negative 2 is negative 2 squared plus 4 times negative 2 minus 5, which gives us 4 minus 8 minus 5, which gives us negative 4 minus 5. Oh, look, it's negative 9. So we knew that's what that was going to become anyway, didn't we? So the vertex formula really does help us figure out maximums or minimums without any issues and any ease. So there's really no reason for us to really look at quadratics anymore. Okay, so the moral of the story is, as far as like completing the square goes, so the vertex formula is now the new ante to play. If you got this guy, life is good to go. All right, so let's go ahead and answer some questions here. You guys ready? All right, so here comes the dirt. It says the path of a driver. Okay, so pretend this is a race car driver is given by this function. Y equals negative 4/9 x squared plus 24 over 9x plus 12. See how dirty that quadratic is? But if we have to complete the square with this, we'll be okay. Okay? Now here's the thing. Remember, everything must be answered within context in this course, where the y is the height in feet, okay, and x is the horizontal distance in feet. So you're probably saying, well, what kind of driver is this? Well, it could be a person flying a plane. Horizontal distance is a common thing, and so is height in feet. Oh, crap. I lied. This isn't driver. I just read the problem all the way. This is diver. So, from the diving board. End of the diving board. So let me give you some context behind this. Here's your diving board. Here's your diver. Doop, 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 doop. He's going to jump and do one of these. Looks very quadratic-like, if you will. So he's going to jump, and he's going to do one of these, right, and go splash, or not splat, hopefully, but splash in our water. Okay, so it's not that bad. So just got to look at context once again. So here's question A. What is the maximum height of the diver? And this kind of makes good sense because he's bouncing up and down, bouncing up and down. He jumps and then makes his plummet, right? So we got to figure out what the maximum height of the diver is, and then finally B is how far must he stand on the end of the board to get max height. So part of this is understanding what the question is asking us. So I'm going to try to really dig this out. It's not a hard problem at all. It's just understanding it. So they say a diver is given by the path. Y is the height. So this is Y. Okay. In feet, X is the horizontal distance in feet from the end of the diving board. So if he's at the end of the diving board, right, does he move? Where does he stand at? So it's the horizontal distance from the end of the diving board. So if he's standing right here, they're talking about his distance when he takes off. So it's this distance. Okay? So now that we got that, excuse me, they said, what is the maximum height? So they're asking us, if you think about his line of motion, they're asking us for this. What is this height from here to here? What is that max height? Okay? And obviously, that's the Y value. It's going to be my max height. That's for A. Now, how far must he stand from the diving board is basically saying how far is he out there so that he gets that maximum height. So if he jumps from the diving board, how far will he be when he acquires that maximum height? So what is this X value? So that tells you that we're looking at the X comma Y, which is, in other words, we just need to use the vertex formula. Okay, so here we go. Vertex formula, negative B over 2A. Look at what B is. B is negative 24, is just 24 over 9. A is negative 4 over 9. Now you better be able to simplify fractions. Negative 8 over 9. Multiply by the reciprocal, you get negative 24 over 9 times 9 over negative 8. Stuff drops, which just gives you a positive 3. So that tells you that X here, how far he must stand, is 3 feet from end of diving board. Pretty simple, eh? Now, to find that height, plug it into your function, f of 3. F of 3, oh my goodness, is going to be filthy. So hopefully it works out okay. 3 squared plus 24 over 9 times 3 plus 12. Oh, that's going to work out all right. That's going to work out okay. So what does this give me? This gives me negative 4 over 9 times 9 plus 24 over 3 plus 12. 24 over 3. So this goes, it gives me negative 4 plus 8 plus 12. This is 4 plus 12, which gives me 16. So, hold on one second. Alright guys, sorry about the delay. I had some visitors at the door. They apparently needed folding chairs for the Super Bowl. Alright, so continuing on here. So when we plugged in 3, right, we ended up getting out 16. Now, what does all this mean? And I'm going to go back to my picture because it really helps us understand. The first time we plugged in negative b over 2a, we acquired the first piece of the vertex, which was 3. Then we plugged in f of 3, which gave us 16. So this tells us that the max height that he jumped when he hit that diving board, bounced up, is 16 feet in the air. So, question A, what is the maximum height of the diver? You better be able to tell me that it's 16 feet in the air, not 3 feet, because that's not his max feet, that's his max distance he moved over. So context is very important. How far must he stand at the end of a diving board in order to get to the max height? Well, he must stand 3 feet. Done and done. All right, guys. So, as I say always, okay, this is not a very, very tough problem, but contextually, it's definitely going to be one of those that are nasty. Let me give you one for class in the morning. All right, so here we go. And then I'm going to go watch Super Bowl. A certain type of power supply, all right, power supply has a power outlet, and this is, you could think about the outlets in your house, output in your house of P in watts, right? So power is normally measured in watts, given by the function. And here's your function. Obviously, it's going to be something quadratic since that's what we're talking about. P of t equals t times 20 minus 10t plus 97. Okay, here's your job. What is t? That's what you got to ask yourself, because it's going to be in minutes, hours, seconds. Okay, so where t is the time in years after launch. Sorry. Time in years. Okay. A, here is your job. Find the max output. And this makes good sense, because finding maximum outputs and minimum outputs help a lot, especially when you're like talking about economics or supply and demand. You want to get maximum bang for your buck using minimum work. So that's kind of two at the same time. Find the maximum output. That's one. And two, output in watts, right? And then when is the max obtained? So when is a question of time. So you better be telling me obtained, what time it occurs. So that's plug in a t, you get out a p of t. This is going to be your vertex. So you got to know what you're looking for, so that whatever you get for t will be your answer here. Whatever you get p of t will be your answer here. All right, guys. With all this being said, this actually is not a tough guy. It's actually a review from what stuff you already seen. You actually got a cheat code now, FYI, knowing the vertex formula, plugging in negative b over 2a, and then plugging that into your function. So once again, in order to go somewhere you've ever done, you need to be open your broad-minded to the strokes that are coming. So keep your mind open. Always look for ways to evolve so you can get the full picture. And I'll see you on the next video. Bye.